Today, we're diving into Studio 5000 to completely demystify the ABS, or absolute value instruction.
Imagine programming factory logic, and suddenly, sensor drift drops your values right below zero. So what do?
That's exactly where ABS comes in. It's basically a math sign stripper, making sure your magnitude stays positive.
Mechanically, it's totally foolproof. Feed it a positive, negative, or even zero input, and your output is guaranteed positive.
Setup is a total breeze. Just pick your source tag to convert and a destination tag for the result.
But watch out for this gotcha. Integer destinations drop decimal places. Always use a real tag for true precision.
You aren't locked into one format either. Effortlessly use it across ladder logic, structured text, or embedded compute blocks.
So how's this actually used? First up, building signal difference alarms for redundant temperature or pressure sensors.
If one sensor drifts, ABS guarantees a positive offset. This lets you trigger a single, super clean, high-limit alarm.
It's also absolutely perfect for PID loops. Say a motor's target must stay within plus or minus 5 units.
Calculating absolute error instantly defines rock-solid in position or at set point windows, entirely without writing any messy, complex logic.
Tracking distance? Whether a robot arm moves forward or backward, ABS treats all that travel as pure positive increments.
For tight manufacturing tolerances, one single comparison instruction can now handle both too high and too low conditions simultaneously.
Ultimately, ABS replaces all those clunky if-then-else statements, rewarding you with beautifully clean, perfectly symmetrical control logic.
It's a tiny instruction with a massive impact. So, how will you optimize your next PID loop using ABS?